Hello and welcome back. Today I have a very little bench multimeter. It's from early 80s and well, it's very small. It is from the brand Simpson and it is the model 467, and I found it on my local eBay marketplace here in the Netherlands, and it actually caught my eye because of all the fancy colors, and later I started looking a little bit in Google and I found out they even made it in different colors. So well, let's find out what it can do. I found the sticker, it has been tested a while ago, and find out what it can do. Here it is, small, also colorful in the bottom. Its stand is still working, rubber feet, all seems to be there. I like the protection is still here. And well, look at all these colors. Look at that. And well, when I pre-announced this in my community tab in my YouTube channel, people already start asking, what is this DIGALOG? What does it mean? So I tried to look, and I come back to that later. I actually did find what I mean with this. It can have voltage, milliamps, ohms, diodes. It even can do min-max continuity test with a peak. Even has a peak hold, and it can even detect very short peaks also. And I think it can even do inrush current. It can only do that up to 2 amps, but if you want higher, 200 amps, then they have a special amp clamp that I don't have here, the current clamp. The connections here are with pins. Let me get the lighting a little bit better. So you need special probes, but lucky me, I have these probes here. So these go in there, and then I can connect here normal probes, and I probably have those. Let's have a better look at the sticker, what actually in here is most of the specifications. And in DC it's 0.1%, not bad at all. In current 0.5, in AC it is 1.5. These are not bad specifications for a 3.5 multimeter. I think it was around 2000 counts, and well, we have like almost, yeah, it's 3.5, so 4 digits, and up to this one up to a 2 or at least 19999. And can we power it on? It doesn't power on. Also, I found a sticker here in the top, and I think somehow it's from Switzerland or Germany, but this sticker here, it is with CH, so I would think it's Switzerland, but it is both Swiss German or German, and it has been tested here 89 of 1992, and well, there are some numbers here, but here it says Einsatzfähig, and if I sort of, my German is not that good, but I think it means like if it is inzetbaar would be in Dutch. So if it's ready for productions, and it clearly says no, not for production. So or didn't meet its calibration, or it is just broken. Well, it doesn't switch on. So let's open it. So not ready for production, but does that mean that it didn't meet the specifications, or somehow, or they just replace it after, because it's from 82 and this is from 89, so maybe they always replaced it after 10 years. That I don't know. And ooh, that doesn't look bad at all. Luckily the battery was taken out. I don't see any damage. I see the beeper here. Huge fuse. Let me do that again. Here. Very big fuse. So the 1000 volt is actually true, because sometimes they say in the specs it's 1000 volts, and then you see the normal fuse, and yeah, well, then I have my doubts. Here also a fuse. I think this is like this is a 2 amp fuse, and this one is the 3 amp fuse. One is fast, one is slow probably, and here we can put a spare fuse, probably goes here. And we just add the normal 9-volt battery, huge buzzer, probably for a continuity test. So, it is, do it like this. Here we go. Yes, it switches on. And here it is. There is even a bar chart. That is pretty cool. Let's just put some voltage in. Voltage, 2 volts. Go get my LBO2. Yeah, wait, I need of course the special probes. Okay, well I have the special probes. I must say the cables are very long. I would say 120. And they are super soft. This is very high quality. Wow. So let's see. One here, ooh, tight fit. One here. And then, yeah, and then you can see it's already trying to, but you see the bar chart is super fast. This is so much better than on the cheap smart meters that have this bar. This one is actually faster than the readout. I put now 100, so I can go one lower. And if we see how fast the bar is faster than the readout. Perfect. 200. Well, I don't know why it's not ready for production, because the voltage is no problem. Go to 1 volt. Wow, this is 1 volt. Let's see if it's really 2000 counts. Well, this one is in its max, this one is in its max. One more, no. Okay, I have the manual right here. And the DIGALOG, it is actually the combination of the LCD display and a fast responding bar chart. So, and they patented this DIGALOG. So that means they were very early with adopting this digital width bar graph. And if I look at the specifications, the normal digits, they update in about a second. For accurate readout, and the bar chart is actually already in 150 milliseconds, so almost a little bit more than a tenth of the speed. So it is super fast. Accuracy, of course, but how can you say that the bar graph is accurate? Because yeah, you will read in big chunks, you know? So it doesn't make too much sense. But the accuracy here is in 5%, they say. So it is 10 times faster, and it is, yeah, we are still in voltage. So let's see what we can do with the peak hold. What if I go to a little bit lower and I say I want peak hold in the minimum. So this is the lowest value it may be measured. Oh, this is confusing. Can I reset this somehow? Because it is now holding the positive peak. This is smart, because if I go, this is my current measurement. And this is the peak it did hold until I go higher. only thing I do not know how I reset my lowest. Oh, you don't. It is just what you're measuring now. So this is my lowest now. Okay. That is kind of smart that you also see what you're measuring now in the bar. Okay, current, let's see, milliamps. I'll put it to 1 milliamp. Milliamps here, milliamps here. Change this one here. Peak hold need to be switched off. And did I do something wrong? I have milliamps here, milliamps here. Maybe the fuse is blowing because I have no readout on the milliamps. No, it's blinking. There's no connection. Okay, so we have to take a look at the fuse here. If I go to the higher setting, then it is this higher fuse. No, it's also not. So something wrong with the current measurement. Okay, we go to the ohms. Would take a while. Ohms. Does it think can do that? Oh, this really takes a while to settle. No, it makes no sense. Okay, well, the current measurement didn't work. That could be a fuse. But I also noticed that the ohms measurement is so very, very slow. And then if you take a range higher, it sort of matches the correct resistance after really 10 seconds. That's way too much. And when you put it on the correct range, so if I wanted to measure 100 ohms and I took the range of 200 ohms, you should have a perfect readout, and it didn't at all. It just stops at 70 ohms or something. But when I put it on the 2K, then it kind of measured the 100 well. So something is wrong there. But it is true RMS, so I like to test that. I have also the DMM Check Plus that outputs a real RMS signal, 100 ohms in a square, 100 hertz in a square. So we should be able to see that it also has a 10K square, but of course that would be too high. With the filtering, I think it is around 1K. So let's have a look at it. So voltage, we want AC. First we can check if the DC is good, but we already saw it was okay. DC on voltage. Yeah, could also still be the current didn't work, and with voltage measurement, that usually doesn't matter too much if the impedance is high. But if you try to do in current measurements, this will make a difference, and in the ohm the same. So maybe there still can be something wrong with my probes or the contacts of my probes. So I like to see that later when I open it, if it's still the case. The voltage seems to respond fine. What if I go now to AC? And it should say also around 5. Yeah, perfect. Because if it was not through RMS, it would have said 5.5 5 or something, 5.6. So this is on 100 Hz. And now I put 10K. Oh, it even works great on 10K. This is really true RMS. This is amazing. It also has continuity test. Then you set it to the ohms range. I think you need to do the 2K in the same setting as the diode testing. And then you need to add the AC button together. And then when you measure, it's actually pretty fast. And loud. Do I have a diode? Yes, I have. I think on the other meter this was about 0.55 volts. Well, that doesn't make sense. No, okay. There is something wrong with also with this measurement here. Okay, I understand the sticker. It's not good for production. Voltage is great. AC, DC worked. Current, I didn't get to work. And also the ohms doesn't make sense too much. Just like it's kind of too much impedance. And also in the diode mode, the voltage was way too high. And that could be the same if the impedance is too high there. Then there is a higher voltage drop. And that would sort of be why the voltage is higher. So there is a problem there. Something is limiting the current, or there is a high resistance somewhere in between. So, well, let me first measure my probes if they are even good. And yeah, let's do that first to check if the probes are even good. And if not, then maybe we can find something in the circuit. Well, we can check also the fuse. Carefully take that out. Okay, this fuse is broken. Okay, that is, or it is super high impedance. This could exactly be the reason. Okay, these are these special fluke fuses. I think I have spares for these. And what about this one? No, this fuse is fine. So we have to have a look at the big one. Yeah, I did find a couple of these fuses, but these are 400, I think, 1000 volts. And these are way too much. The size is the same? No. These are fluke size, it's this size. But I think this one is 400. Yeah, indeed. The blue ones are not 3 amps, they are 440 milliamps. I checked my order at AliExpress. It was a nice deal, by the way, because you can spend a fortune if you want on these fluke fuses. But you can also find them in alternative places. How original is it? I can't tell you, but it will do the job. I will not measure above this 440 milliamps, so we'll just put it in, and then we can check if the ohms range and the amp ranges are working again. And yeah, interesting. And then later I will need to find the 3 amp fuse, of course. Okay, fuse is replaced. Let's see. Common here. Milliamps here. Milliamps DC. Let's put first to 2 milliamps. and then we will measure one, power it on. Yeah, this one is readable. Get my LBO2. One. Well, let's see. Yes, spot on. Look at this. Wow. 2 milliamps. And you can see the bar is super fast. 2, 3. The bar is there already, and then you see the digit still stabilizing. Oh, kijk, and now we have another problem again. The current is stuck. I'm here at 19, and this one is again taking a long while. Almost like the capacitor needs to charge. So continue this project. For you it's the same video, for me it's a month later. I don't remember exactly, but I think that the readout was a little bit slow and the bar seemed to work fine. But then I remembered in one of my other videos with Nixie multimeters that I said always start by cleaning the switches, because the switches can also cause impedance. So let's open it up further. So we'll just try to open this. Remove the battery maybe first. So. I am not completely sure how to do this. It doesn't seem stuck. Maybe I can just push it by the buttons. Yes, I can. And then, ooh. It's a little bit dirty on the inside. Seems like some foam that degraded. Then I should have the same here on the front. Yeah, I think they put foam. It's all sticky. Maybe I can just wash this. Oh, kijk, it goes off. Okay, so if I remove the switch, yeah, I need to wash this. Okay, well, I will just desolder the switch. There are some, looks like transistors, but they're probably used as diodes to make the selection between this and this. And that is peak hold plus and minus. Yes, it's probably done with some diodes. Let's see if we can open a little bit more. It looks like it's all with connectors, to be honest. Connector on the, I think we can just open it like this. I hope. Let's see if I don't break anything. Yeah, it goes. Does this also goes? Oh yeah. Ooh. Scary. Okay, there is some power plug still stuck. This is a bit scary, but I need to unplug the power. Okay, that is loose. Well, in the end, it doesn't seem too much of a problem because it just says here red and black, and that was just pushed on it. So I use my little plier just to pull it off, and the wires are still here. So that is okay. Yeah, we can just have a look if we see something is not good, but I will start cleaning the switches first. Okay, that is back together. This I wash simply in the sink with the white sanding fluid. Back to its original color, looking a lot better. All we need to do is now polish the display. Okay, I have the little calibration manual here. So we need to set to 200 millivolts, 200 millivolts. Let's get 200 millivolts here. We have 200 here, so that is okay. Then we have the let's see, AC is 203, that is the middle one. I'm having here now the DMM check plus, and we will get it to 5 volts. Is that also on this one 5? Not completely. Okay. Okay, after the calibration looks a lot better. 160 millivolts. Can we do a little bit higher? Yes, we can. 1.6 volts. Here we have it. 1.6. Can we do a little bit higher? Probably 16 volts. 16 volts. Then we have also AC. Let's try 5 volts. We do some resistors first. Switch this off, go to ohms. First in the lower range we have 100 ohms here. 100, there we have it. Then we go to 1K. Look at that, that is 1K. 10K. 10K. 100K. 100K. Perfect. And we can also do AC. Put it to AC, to on, put it to voltage. 5 volts is the only thing I have, but it is exactly 5 volt and it is RMS. So, oh, something went wrong. It is still in ohms. Look at that, 5 volt through RMS. So the sweet Simpson is working again like new. It is pretty reasonable calibrated right now. And look, it has its own color back. And it's pretty cool. And this was probably one of the first with DIGALOG with the bar chart. And well, as we know now, it is being copied by a lot of other brands by now. So that was pretty cool. It was actually good that I put it away because then I could think about it a little bit more. And then, yeah, it turned out to be my old advice. Always clean the switches first, because somehow if you get an high impedance and your values can go all the way, or it's very delayed. I've seen that before. And after polishing also the display, look, it is super shiny. And it's very nice. I looked a little bit more on the internet. You also find it blackish, or there's all kinds of different colors. I think they liked it a lot in that time. It goes back into my collection. Thank you for watching, and I hope to see you next time.